So here is a polynomial, the general form, f of x equals a n x to the n plus a n minus 1 x to the n minus 1, so on, plus a 1x plus a 0. So let's assume that the leading coefficient a n is not equal to 0, which makes it an nth degree polynomial. The possible zeros, the possible rational zeros of this, according to the rational zero theorem, is equal to factors of the constant term. The constant term is a0 divided by the factors of the leading coefficient, which is a n. Now let's look at an example. F of x equals x cubed, which means 1 times x cubed, plus 2x squared minus 5x minus 6. Minus 6 is the constant. So the possible rational zeros is equal to factors of minus 6. Minus 6 is the constant, and factors of positive 1, which is the leading coefficient. Factors are numbers that divide, whole numbers that divide a number. So factors of negative 6 are plus or minus 1 because 1 divides 6, plus or minus 2 because 2 divides 6, plus or minus 3 because 3 divides 6, and plus or minus 6, of course, because 6 divides 6. So these are all the possible factors of negative 6. Now the factors of 1 are plus or minus 1. Now we split it to see what, so we get plus or minus 1 divided by plus or minus 1, which gives us plus or minus 1, plus or minus 2 divided by plus or minus 2 gives us plus or minus 2, plus or minus 3 divided by plus or minus 1 gives us plus or minus 3, plus or minus 6 divided by plus or minus 1 gives us plus or minus 6. Now we know that these are the possible rational roots of, or rational zeros of, this polynomial function. Now if the numbers are small enough, an easy way to check if they are roots is by just plugging the numbers into the function. 1 is easy enough to plug in and figure out whether it is a 0 or not. So when we plug in a 1, we get a number that's not equal to 0. So x equals positive 1 is definitely not a 0. Now we plug in x equals negative 1. When we plug in x equals negative 1, we do get a 0, which tells us that x equals negative 1 is a 0. So if x equals negative 1 is a 0, we add 1 on both sides to get x plus 1 equals 0. That tells us that x plus 1 is a factor. If it is a factor, then it must divide x cubed plus 2x squared minus 5x minus 6. So when we do long division, watch my video on long division if you don't remember how long division is done, or use synthetic division if that's what you're comfortable with. When we do long division, this is what we get. We get a remainder of 0, which tells us that f of x, which is equal to x cubed plus 2x squared minus 5x minus 6 is equal to x plus 1. So when we divide by x plus 1, we get x squared plus x minus 6. So now this is a quadratic polynomial, so we should be able to factor it. If not, we can use the quadratic formula to find the other 2 zeros. So let's see if this can be factored. So x squared plus 3x minus 2x minus 6 should work. So that's x plus 1 times x plus 3 minus 2 times x plus 3, which is equal to x plus 1 times x minus 2 times x plus 3. So now we have all the factors. We've got the expression completely factored. So we can find out all the zeros of this polynomial. So x plus 1 equals 0 obviously gives us x equals -1. We already know that. X minus 2 equals 0 gives us x equals 2. X plus 3 equals 0 gives us x equals -3. So we have all the three zeros of the polynomial.